All right, let's talk about one of the most ridiculously ambitious energy projects I have ever seen. We're talking about a plan so huge, so out there, it honestly sounds like something straight out of science fiction. But is it? Or is this what the future actually looks like? I mean, really think about that for a second. An entire city. All the lights, all the trains, every single data center, everything that makes a modern city tick. And you're powering it from 40 to 100 kilometers away. Just for context, that's about the distance from London to Baghdad. It's nuts. We're talking about sending electricity from one continent to a completely different one. And the crazy part is, this isn't just some fantasy. This is a real mega project called the Australia-Asia Power Link. The whole idea is to soak up all that incredible sunshine in the Australian outback and shoot it all the way over to Singapore. So you're probably wondering, how on earth would that even work? Let's break down the absolutely mind-boggling scale of what they're trying to build here. The whole journey for this electricity really happens in four main stages. First, you've got a gigantic solar farm right in the middle of Australia. Then, that power has to travel across land to the coast. Once it gets there, it has to be converted, kind of packed up for its long trip. And then, for the grand finale, it dives under the ocean and travels all the way to Singapore. Let's start with where the power comes from. The solar farm, or solar precinct as they call it, is planned to be 12,000 hectares. To give you some perspective, that's an area bigger than the entire city of Paris, just covered in solar panels. Okay, so you've made the power. Now what? Well, it has to get to the coast, and that's no short hop. It's going to travel along a 788-kilometer overhead transmission line, slicing right through the massive Australian Northern Territory. And here we are at the most jaw-dropping number of them all. The final leg of the journey is through a 4,200-kilometer subsea cable. This would be, by far, the longest power cable of its kind in the entire world. So we get the route, but sending electricity that far, that is a massive technical problem. So let's get into the secret sauce, the technology that actually makes this whole energy superhighway even possible. And that's the million-dollar question, right? Because if you use the kind of technology in our normal electrical grids, you lose almost all of that energy as heat before it ever got close to its destination. It would just fizzle out. Well, the answer is something called high voltage direct current, or HVDC for short. It's basically a super specialized system that's purpose-built for one thing: moving enormous amounts of power over huge distances with incredible efficiency. See, our normal grids use what's called alternating current, or AC. The best way to think about it is like a big, messy crowd with electrons kind of shuffling back and forth. There's a ton of friction and a lot of wasted energy. HVDC, on the other hand, uses direct current. This is way more like a disciplined army marching in a single, straight line. Because it's so orderly, it dramatically cuts down on the energy that gets lost as heat. It's perfect for these epic, intercontinental journeys. And the difference is just staggering. Seriously, look at this. Over a distance of 1,000 kilometers, a regular high-voltage AC line could lose up to 35% of the power it's carrying. But with HVDC, that loss gets slashed to around 3.5%. It's literally 10 times more efficient. That efficiency is the only reason a project like this is even on the table. Okay, so the vision is huge. The tech is there. It all sounds great. But building something on this scale slams you right into some very serious, very real-world problems. Let's get into the reality check. A project of this magnitude needs a ton of specialized, heavy-duty gear. And, as Ben Bosher from the energy research firm Wood Mackenzie points out, one of the most critical pieces, the power transformer, is in dangerously short supply right now. In fact, some projections show that we could be looking at a 30% supply deficit for these essential transformers by 2025. You just can't build an energy superhighway if you can't get the parts, and right now, the world simply isn't making enough of them. And this isn't just one simple problem. It's more like a perfect storm. You've got global electricity demand soaring, a massive boom in clean energy projects all over the world competing for the same parts, aging grids that need replacing, and labor shortages in manufacturing. It all adds up to a massive global bottleneck. And if navigating the supply chain wasn't hard enough, there's an even more complex challenge. How do you build this thing responsibly? This brings us to the immense environmental balancing act they have to pull off. The environmental impact statement for this project is literally thousands of pages long. And it has to be. The review process is incredibly thorough. looking at absolutely everything, from the ecosystems on land and in the sea, to cultural heritage sites, to the impacts on local communities. And this is exactly why it's so complicated. The project's footprint starts in the dry, remote Australian outback, which has its own unique ecosystems. But then it travels all the way to these sensitive coastal habitats and fragile marine environments. Trying to manage the impact across such wildly different landscapes, well, it's a monumental task. So, what do we have? We have an unprecedented vision backed by some brilliant technology, but it's running head-on into unprecedented global and environmental challenges. So what does this all mean for the future of these kinds of energy megaprojects? This really is the core tension of the whole thing, isn't it? On one side, you've got this incredible world-changing vision, a potential blueprint for how we could share clean energy across the entire planet. But on the other side, you have the cold, hard reality of global supply chain meltdowns, incredibly complex environmental hurdles, and just enormous financial risk. And ultimately, a project like this forces us all to ask a really big question. As we try to tackle this massive energy transition, are these giant globe-spanning projects the kind of bold solutions we need? Or are they just a gamble that's way too big to take? The answer to that is probably going to define how we build our world for the next generation.